Here we would like to find the eigenvalues and the eigenvectors of the given matrix. Let's start by remembering what the eigenvalue problem is. It tries to find a vector v that, when applied the transformation given, gives just that same vector times a scalar, meaning it does not get knocked off of its span by the scalar. Now we can rewrite this to make the left-hand side, which is matrix multiplication, equal to matrix multiplication to the right-hand side by adding the identity matrix, which is really just like adding an equivalent of 1 in matrix form. And then we can subtract the right-hand side from both sides of this equation and factor out a v, which leaves us with this right here, which is kind of interesting because now, unless we have the trivial solution that brings us to have this product equal to 0, the determinant of this matrix right here must be 0. And this matrix right here is going to be 4 minus lambda, 8, 0, and negative 5 minus lambda. So now, to indicate that I'm taking the determinant, I'm going to have the vertical brackets, and this is going to result to lambda minus 4. I'm factoring out a negative, and lambda plus 5 minus 0. So I'm not going to write anything here. And so this whole thing has to be equal to 0, which means that lambda can either be equal to 4 or lambda can be equal to negative 5. These are our two eigenvalues. So we answered the first part of the question. These are our eigenvalues. And now what we want to do is we want to plug them back here. So let's do that for lambda, and I'll take some more space. For lambda 1 equals 4, we're going to have 4 minus 4, which is 0, 8, 0, and negative 5 minus 4, which is negative 9. And now we're not taking the determinant anymore. We're multiplying it by our vector v, which has, we'll say, coordinates x and y, and that has to be equal to the 0 vector, which has all entries equal to 0. Because remember, these are the lambdas that allow this expression to be true. So now we can solve for x and y. And if we do that, we'll have 0 times x, 8 plus 8y equals 0, and negative 9y equals 0. X does not appear at all, so we can choose x to be any t, and y is just going to be equal to 0, which means my vector is going to be t times 0, t and 0. This is going to be my vector v for the first value eigenvalue. The second eigenvalue is going to give me some other matrix. Let's see, we're going to have 4 minus negative 5, which is 4 plus 5, which is 9, and 8, 0, and negative 5 plus 5, which is 0. Now this is going to give us what? X, y is just going to give us 0, 0 here, which means we're going to have 9x plus 8y equals 0, which means that 9x has to be equal to negative 8y. Or x has to be equal to negative 8, 9y. So if y is 1, then x has to be negative 8 over 9. And this is our other eigenvector. Okay, so now our two answers are this and this right here. I hope you were able to follow along, and I'll see you next time.